Welcome back, everybody. We are continuing with George Xydis from Department of Business and Development and Technology from Aarhus University, and he will tell us about small-scale plant factories with artificial lighting and wind energy, microgeneration, a multiple revenue stream approach. George, welcome, and the screen is yours.
Hello, thank you very much. I'll try to share my screen now, and I hope you can see the presentation now.
Not yet.
Yeah, hopefully soon.
Here we go.
And I guess now it's full screen.
Yes, more or less. Yes, it's all right.
Okay, good. Thank you very much. I'm sorry about my voice. It's a bit strange, but I've been tested. I have some symptoms, and I've been tested yesterday for corona. Thank God it's negative, but it seems that apparently every other virus is still around, so they have not been eliminated from corona. So you have to bear with me with this stupid voice. Anyway, I'm an associate professor at Aarhus University, and we did 3-year research actually on how to couple artificial plant factories with artificial lighting together with wind turbines, and that's what's this all about. It's a sum up of this work. Practically what we have to start from is what is vertical farms. Vertical farming is the practice of growing products in the vertical stacked layers. What we have here is some large-scale vertical farms. Also, our small growth chamber is over here. We need thermally insulated growing areas. What we have is ventilation fans. We have CO2 filters, LED lighting, hydroponic and aeroponic and automations, and so on. Why is there a need for vertical farms and demand for vertical farms? Because we are throwing away 44% of our by weight of our fruits and vegetables, and of course by kilocal almost 15%, 13%, and we are producing all our products far from the demand centers, which are in the cities, and this situation will get worse. The challenge there for the vertical farms is practically the electricity costs. For all these that we mentioned before, lights, especially lights, we need 7 to 9 euros per square meter per month. So imagine what the cost is for large scale vertical farms and plant factories. Where is the business opportunity with this one? Well, in those countries that there is this let's say power trading, electricity trading opportunity, which is in most of, at least in the Western world, there is a chance that you can adjust your lighting requirements depending on when the electricity is cheap and when the electricity is expensive, to try not to offer to your plants lights. So there you can optimize in some way every day based on the spot price and based on the price that you have from the day-ahead market and so on. So this is where the business opportunity comes. So far, the large-scale plant factories, they are not using that. They just simply provide darkness for the night hours and light for the day hours, or the other way around, depending on when it's cheaper. So that's all they're doing in terms of optimization. So this is where we come and we offer our methodology. Via this 3-year project that we worked on, PhD project, we managed to actually couple all the plant growth parameters that we're looking at, like photosynthesis and temperature and relative humidity and CO2 and so on, with the electricity pricing, and we managed to actually have some load shifting there to move from one area to the other, the load that we had to provide, especially for lighting, to the vertical farms. And then at the very end, we managed to have every day a different lighting schedule for the plants. And we managed, of course, to optimize this counting and measuring all the different parameters that they mean that we have a growth in our facilities. Otherwise, this didn't make any sense. What we realized is that we managed with our methodology, we were offering intermittent lighting to plants. That means that we had the plants receiving light for some hours during the day for 10 minutes, and then for the rest 50 minutes it was dark. And then we did that throughout the day several times. So we realized that we can increase the yield, at least in basil, that we tried by 20 to 30%, and we can reduce the electricity costs by 50%. In practice, for someone who who's operating a vertical farm, this means, at least for basil, that we did our experiments, 1 crop per year. So when you have all your operating costs there, and you just simply have 1 crop more per year, that's net profit. And these are our results. We managed to go from these simple 8 hours of darkness and 16 hours of light to reduce it down to 10 hours of darkness and 14 hours of light. And we managed to reduce the energy demand and at the same time increase the dry biomass. And we can see, especially from day 12 until day 20, that there was an opportunity there. There are some examples here without the energy optimization of our basil and with the energy optimization. The market is big, and it's becoming bigger and bigger. We have the container farms, we have the vertical farms, of course, we have the greenhouses with artificial lighting, and something that I haven't added here, it's the cannabis also market that's growing super fast. So at the very end, based on our publications, we managed to have 25% less operational costs and 30% more of yield increase. But how is that related to wind energy microgeneration? That's our topic here. Well, what we did, I did have some access to data from Greece. I'm Greek, if you haven't figured out that yet from my accent. And I did have some data from an area in northern Greece. So we did some wind resource analysis based on this data. We tried to find the available area for the small wind development. And then we managed to do some wind farm planning and calculate the energy yield results. And this, we managed to couple that with the opportunities for the plant factories. And we examined some scenarios. So we did some statistical analysis in the wider area of the city of Komotini, which is in northern Greece. And we managed to actually have an initial siting of small wind turbines, 50 kilowatt each. We ran some software tools like WASP, and we managed to estimate that from 20 small wind turbines, we can get approximately 3.5 megawatt hours per year. And then we did some calculations about the vacant apartments and buildings that they're not right now used, and how many these are, and they were more or less calculated based on the population and housing census, that they were around the population of course, I forgot to say that the population of the wider area is approximately 60,000 people. And then we did some calculations, and we realized that the available dwellings are approximately 4.5 thousand in the wider area. Based on our publications and based on the results that we've found, we managed to estimate that approximately a vertical farm that will work in a flat of 100 square meters will probably require around 1,500 kilowatt hours per year. That means immediately, since we had 4.5 thousand buildings, that means approximately 6.8 megawatt hours annually. So from the annual net annual energy production that we calculated based on the WASP software. We calculated that we can meet less than 50% of this demand from the small wind turbines if this whole system was working off-grid and not being connected. And then we started testing some scenarios. We tested some scenarios in terms of internal rate of return and the payback period. Our goal was to create for the investors in the small scale wind industry an alternative revenue, stream revenue. So we tried to test some scenarios with having some different selling prices of the products that we could sell. So, for instance, the scenario which had underscore TOM, it means tomatoes, small tomatoes that you can grow in those areas, in those vertical farms. 20% means that 20% should go from the energy produced to the vertical farms of the area, and then the 80% can go to the grid, can be actually used with the tariff or in some different schemes. And this is the price offered that was estimated. Of course, we had some scenarios. We tested prices from 80 euros per megawatt hour to 225 euros per megawatt hour. So from really low to really high up, because it's at least as far as I know, until a year ago or so, it wasn't yet fixed. So there was a discussion about this, at least in Greece, about this amount, what the small scale wind projects will receive. And then we got different prices, selling prices for basil, for tomato, and for lettuce, which are the most three, let's say, the most three in demand from vertical farms. And then we tried and tested some scenarios. Based on these analyses, we realized that from all these scenarios, there were some earnings that were coming from the feed-in tariffs, let's say, earnings, or whatever scheme in other cases, but at least for Greece, for the small scale industry, there is still this supporting scheme in place. And then we had the calculation of the total earnings. So in some cases, we realized that you can get your money back as an investor in 2 years, which was amazing. And we had even more than 100% of IRR, of internal rate of return. But there were other cases that you could take your money back as an investor in 6 or 7 years with a lot less in basil. In lettuce, things were more or less the same. That was, you could get your money back to 6 or 7 years if you were paid for this scenario. For instance, here that means 125. 5% only, the rest 95 should go to the grid, and it was lettuce. So that was this scenario. But on the other side, you could, if you were really paid high up, and you had a 20% share for the vertical farms for lettuce, you could earn a lot more, and of course get your money back in more or less 2 years. We also tried and tested some extreme scenarios with really low payments, like 80 euros per megawatt hour, and we realized that cherry tomatoes were actually not that profitable, and you wouldn't be able to have an alternative revenue. In fact, you would have negative, in several cases, negative internal rate of return. That means that you'll have a loss and not profitability. So that was not something that they should think of it. But in the case of basil and of lettuce, the situation was not like that. And you could even get your money back quickly and have a high internal rate of return. And then we had some analysis that what could happen if you had fewer wind turbines. We can see that the payback period, even with 2 wind turbines, would have been 6 years. So not that bad, but even with only 1 wind turbine of 50 kilowatt, then the profitability wouldn't go really up. You had to wait for 13 years in order to get your money back as an investor. So more or less what we ended up and what we realized is that even with one wind turbine, you could even get your, actually with two wind turbines, small wind turbines, that means 100 kilowatts. In our case, you could even get your money back and you could have a viable investment. Unfortunately, tomatoes IRR, in all cases, it was between 2.5 and 11.3%, while the 11.3 was okay, bearable, and you could live with that, but with the 2.5, then that's not a viable business. And of course, there were cases that we had negative IRR. And of course, for basil and lettuce, things were much better, and you had you could even exceed 100% and get your money back in 2 years. And of course, there were extreme cases where it was assumed that the small-scale wind turbines feed-in tariff could go at 80 euros per megawatt hour. The IRR for tomato was negative. That's and this is the publication that all this data come from. Thank you very much. I've been struggling, as the only thing that we can say now that I've been struggling, like Ken has. We developed this a small company, a startup from Aarhus University, Verdecube, that's now is starting its journey, and we're struggling because we're thinking as scholars, as academians, and actually we have to have a different mindset, which is not easy. At least for us, it's a whole new world with a lot of things when you go to the business world. But okay, it's a nice journey, and we're so far we are enjoying it. That's all. I don't know if you have any questions. I should stop sharing my screen now, I guess. Thank you very much. Any questions? Anything?
Thank you very much, George. Yes, I hope there'll be some questions for you, because from my point of view, it was a very interesting study you've made here, and I wish you luck with it in the future.
Thank you very much.
Yeah.
Thank you.
Very often people are just having a thought before they come up with the questions, but we do also have the possibility that when your colleague from Greece actually is having the next presentation, and afterward that we will have some kind of networking, what to say. So
perfect. I'll be around, so we can always discuss later.
Oh, that's good. That's good. But still, are there anybody who is having any questions? It doesn't really seem so. And then I will thank you very much, George.